Hello, and welcome back to our Intro to the C programming language. This is session number 5. Quick recap from last time. We went over pointers, dynamic allocation, the size of operator, multiple layers of indirection, pointer and address arithmetic, flying overhead. Anyway, among a handful of other smaller topics. A little bit of a housekeeping before we keep going. Last time I brought up my Windows text editor of choice and my command line. I have been told this may have been a little too much too quick and to describe the tools that I've been using. The compiler I used is called GCC. The terminal shell I was using is called bash. And to get those on Windows, you need a utility called Cygwin. Cygwin is a free and open source utility that is a port of a handful of useful Linux tools over to Windows. When I'm working, Linux is my operating system of choice, but I've been working on Windows here because I figured it'd be a little more familiar for you. My text editor on Windows is Notepad++. It is very simple and very bare bones, but it has syntax highlighting, multiple tabs, other useful features for getting started, and it's quick and easy for if you just need to write a little bit of code. If you are on Linux, most distributions come with GCC installed by default. So if you're on Linux, you probably already have GCC. For people on Windows, again, Cygwin has the GCC toolset available in the setup tool. If you are on Mac, I don't know enough to make a good recommendation, in all honesty. I hear Xcode is the editor of choice, and I think that comes with the Clang or Clang compiler, but I don't know for sure how to get GCC. Clang and GCC operate pretty similarly, though, so you should be good to go there, honestly. The command I used last time to compile the 3 C files are GCC star.c-o intro.exe with spaces in between every major bit. You can see it right here. To break down what that does one word at a time, basically, GCC is just the name of the program, and everything after this is arguments to GCC. This star.c basically says, create a list of all files in this directory that end in .c. So any file whose last 2 characters are .c, put it into the list and copy paste that right here. So this is how I got all 3 of those files at once. This -o says that the next thing in the command line is the name of the file that I want you to output to. So in this case, I said that I want the executable file that GCC produces to be named intro.exe. If you do not specify this, what you get is an executable file named a.out. This can be problematic on Windows because Windows expects all executable files to end in .exe. On Mac and Linux, this doesn't matter because the way that files are set as executable in those is a matter of setting some metadata bits. All of this is gone into in more detail in an Intro to Linux development course that I will be recording later. Other useful flags for GCC are -wall or -wall, which sets all warnings to, which tells the compiler to output every possible warning if it finds them. -w extra or wextra, which does the same thing but more. So typically you want to use both of these together. -w error tells the compiler to treat warnings as if they were errors. I learned C using this. I recommend other people learn C using this, specifically because it forces you to write clean code. and it forces you to treat errors as what they are. The compiler telling you that you have done something wrong, even if it's not necessarily going to break your code. Dash ANSI and dash pedantic are useful for learning raw basic C, but we're actually going to go into a feature in this slide deck that will disallow you from using ANSI at least, and probably pedantic. Basically, ANSI makes you conform to one of the original C standards, C90 if I recall correctly on GCC, and dash pedantic makes the compiler a lot more aggressive about making you conform to that. So this session is going to be going into the nitty-gritty of macros, when to use macros, how macro inlining works, among a handful of other things you can see here. So, macros versus functions. As you've seen already, macros are a function of the preprocessor and not the compiler, which means that macros are just telling the preprocessor to generate code in place. If you've been paying attention, you'll be able to tell what's going to happen with this code over here. Just going to see this number and replace it with the number 10. See the number here, so we replace it with the number 10 in place. The function solution over here will semantically do the same thing. It'll just output the number 10 to the screen, but it has a bit more overhead here, and it works different under the hood. This number here is calling this number function up here. What that does is it means the runtime has to allocate a new stack frame as we enter a new scope here. Then when the runtime gets to this line of code here, well, it has to allocate memory for that 10 to take up somewhere, and pass that back to this printf here. So that's more memory that has to be allocated, and that's more overhead. So this code, despite doing the exact same thing as this, is considerably slower, even if modern computers are still fast enough that you're not going to notice a difference. It's still like on the order of microseconds. We see another GCC command line down here, this -e, basically tells the compiler to pre-process it and then spit out the resulting source code to the terminal window to standard out. We see on the next slide what the result of that is. Above this line here, there's basically just a bunch of random declarations from standard io.h. Same goes for above this line here. So the main thing we care about is this chunk here, where we see the find and replace happened here. So the word number is replaced with the number 10. And in this chunk over here, we see the preprocessor didn't touch this bit of code at all. So why use macros? What's the point of having them in the language? Macros in general are not recommended anymore because they can cause a handful of issues. Modern compilers and modern C standards support the inline function qualifier as a kind of replacement for them. Some of the disadvantages of macros is that they're not type checked, so the type safety of C is just thrown out the window. They can be rough to debug because they're just simple cut and paste, find and replace. Macros aren't namespaced, so macros in one section of code can potentially affect others if, for example, that name gets used, or if you have another macro with the same name, that macro will work across all of your code, and it can potentially cause issues. And macros can cause side effects. Because it's just copy-pasting code in place, if you're not careful, this can result in side effects and data corruption that weren't intentional. That said, the advantage of macros is that they can be type neutral with a little bit of effort. They're set directly into the code, so any function call overhead just goes away, as does any memory allocation besides things that are declared in that macro. So they can be faster, they just need to be used very carefully and very judiciously. In C++, it's possible to get around the type neutrality with templates, and in modern C and in all C++, I think. No, it wouldn't have been in C++ 98 because the inline thing was C99. So in recent versions of C and C++, the inline keyword helps get around the inlining and the function overhead. So what are macros used for? C macros do what all macros do. They take something small and they expand it into something big or longer. One reason to do it is, as you mentioned, it's performance. Because they're all in line, there's a lot less overhead to deal with. For an example of this, you can see the FD underscore family of macros. What these do is they deal with file descriptors. If I recall correctly, and I don't know for sure because I've never used them myself, but if I understood what I was reading, they are used to deal with synchronous use of files on the disk, meaning that you could have multiple programs writing and reading to the same file, and these macros can be used to signal, hey, I'm done writing to this file, it's safe to read from it now, or hey, there are people reading this file, maybe you shouldn't be writing to it right now. I kind of skipped over this, but it's actually pretty important. The inline function qualifier is not a mandate to the compiler, but is instead a hint to it. In general, this is a good thing. The compiler is smarter than you. This is a running theme here. The compiler knows or is able to calculate when the overhead of a function is insufficient to actually matter when it's generating the machine code for something. However, if you really want to make sure something is inlined, you've got to use a macro. The FD underscore macros are actually just bit manipulation under the hood. And while it's possible that you could write out all of the bit twiddling yourself, it can be a bit of a pain, and it's more confusing than it has to be. Assigning a name to these operations makes it so that it's a lot easier to read. And putting them in a function just adds overhead that's really not necessary. Macros can do some things that functions can't, like token pasting or stringifying stringifying tokens. Because the preprocessor runs before the compiler does, it can generate new variables for you. This can be a shorthand way to declare a whole lot of different functions at once. So what you could do, for example, is you could have a macro that has the skeleton of a simple function, but all of the like data type names would be replaced with the variable that you pass to the macro. Then later in the code, you call that macro with the name of whatever data type you need. So you could say generate function for int, generate function for float, and you'll be able to just have multiple versions of the same function. This is pretty similar to how C++ templates work under the hood, but not exactly. So, macros can help write portable programs. And this is part of what's called defensive programming. It's it's writing code while anticipating later hiccups. So if you need to write code that deals with multiple platforms, then it might be useful to have a macro to deal with certain differences between them. This will allow This will allow the nitty-gritty details to be handled in line while the majority of your code remains normal. Additionally, you can have macro definitions hidden behind if-def preprocessor commands, so you can actually change the macro depending on what platform you're actually compiling for. In this situation, we just see a simple add macro, which actually doesn't do what it says it does. But this is just a quick example that that macros can be treated like inline functions. So this gets expanded into b plus c over slices, resulting in, let's see, in this case we get 16 over 8, so this will spit out 2 to the screen. So when do you use a macro instead of a function? Most of the time you want to be using functions or just writing things out verbatim, but in some cases you do need to use a macro. If you're doing things with token pasting, you need to be using macros. If you're dealing with line numbers or file names, or specifically line numbers or file names of your source code, for example, generating error messages, you need to be using macros. Dealing with things that aren't expressions, so that would be anything that doesn't resolve to a value. You need to use macros for that, because functions can only deal with expressions as arguments. Expressions or data types, but for example, how many implementations of the offset of command use a type name to create a cast operation? So let me see if I remember what this is. The offset of command will tell you, suppose you have a data structure in memory. In general, the compiler tries to make all of the data in this structure align nicely onto like 4 or 8 byte chunks of memory. And the offset of command can be used to determine essentially where a piece of data is relative to another one. But that's kind of complicated, and it's very situational, is what I'm saying here. There is a macro to get a count of array elements. It can't be done with a function because under the hood, arrays are all just pointers and pointer arithmetic, which is why you can use the subscript operator, those square brackets, when dealing with pointer arithmetic, as well as with arrays, because under the hood, arrays are just pointers. And we went over kind of type neutral / polymorphic code earlier. Generating functions with macros in C isn't true polymorphism, but it's about as close as you can get in C, without basically writing all of the features for C++ yourself. So, using a macro for debugging. You could see an example of having macros hidden behind if-def here. So if-def debug, we define debug print for x as printf x. So what this will do is, in line, it will just call printf with whatever you pass, with whatever string of code you pass to this macro. If debug is not defined, debug print is an empty do-while loop, which just does nothing. This is probably about as close to a null operation as you can get with a macro, without just defining it as empty. So, and then we end the if because the preprocessor needs that. We see an example line for this here, so we in parens pass this format string and these variables, and under the hood, this will just get replaced with call printf for these arguments. The extra parens are necessary because some C compilers don't support having variable arguments in macros. But it's sometimes worth trying without it if it makes it look prettier to you, but ultimately it's a matter of how much are you willing to tinker with it in the name of making your code look pretty. So, in summary, macros are useful tools that need to be used judiciously. Macros are most useful when you absolutely need something to be inlined, when you need to repeat something frequently without wanting the overhead of a function, or when you need to deal with certain meta details of your code, like line numbers and file names of your source code. Under most circumstances, you're going to want to use just functions, and if you're feeling like something really needs to be inlined, I recommend letting the compiler decide for you and just giving it the gentle nudge with the inline keyword. Where you put that inline keyword is before the data type of the function. So if you remember earlier how we actually up real quick, I can make a new file and send a view here. If you remember last time around when we made this static int here, the way you would use the inline keyword in C is you would just say inline func, inline int, inline func, just void or int args, or whatever kind of arguments you needed in here. That's basically macros. It's a little complicated, but ultimately there isn't a whole lot to go into with them, which sounds contradictory, and it kind of is. Macros are weird. If you need any of the source code from last time or from future sessions, if we end up using them, the source code will be uploaded to the course website, separated by session in which it was used. Next session, we'll be going in detail on arrays and how to use them, and how to deal with things like I need to do something on every element of an array. As always, there are private sessions for software design and software engineering and C and C++ programming available on the website. Thank you for joining us.